take a look at probability. Remember, probability is the number of times you can get success, or the number of successes, to the total number. So, for example, we're going to take a look at this first page here. Probability of a 4-letter name. Well, we had 1, 2, 3, 4. So success, we read this as probability of. It's kind of like f of x, but it's the probability that a 4-letter name. So if we have all these names in a hat, what's the probability that we're going to have a 4-letter name? Well, we had, it looks like 1, 2, 3, 4 of them. So 4 names with 4 letters. So 4/10 reduces to 2/5. So those are pretty simple. If you don't remember how many cards are in a deck or something like that, you may want to watch the Cards 101 video. But let's take a look at one of these. These are actually just cards. They're not really a deck of cards, just little cards that somebody made. So the probability of getting a 2. Well, we only have one card that's a 2 out of 12 total cards. Now when we get to a deck of 52 cards, we want to know what is the probability that we get a face card. Well, a face card comes from a king, jack, and a queen. And so we have 3 cards and we have 4 suits. So we have a total of 12 cards out of, so 12 face cards out of a total of 52 cards. And then we would simplify that, and that simplifies down to 1/13. Notice probabilities are written as fractions, not percents. So it's between 0 and 1. 1 being it's going to happen, there's a 100% chance of it happening, or 0 being it's never going to happen. So then you have a little spinner here. The hole in the paper went through 4, but you can do that. On the back, or on the second page, we have inclusive. An inclusive event means that it's something that can happen at 2 things that can happen at the same time. So, for example, if I wanted to find the probability that you were a freshman in this class, well, this might be all of the names of every freshman. And this might be our Algebra 2 class. So the people who are freshmen are the people in the middle here in this common area. Their name would be written under freshman, and it would be written under Algebra 2. So these are not mutually exclusive. They are inclusive, meaning that there is some overlap. Mutually exclusive means that they can't exist. It's one or the other. So, for example, you're a freshman or you're a sophomore. You're not a freshmore. There's no way that you could be both things. You're one or the other. So if we look at number 3, probability that it is a king or a queen. Well, you can't be a king and a queen at the same time. So according to that, it's probability of A or B. So it's the probability of A plus the probability of B. So the probability you get a king plus the probability that you get a queen. I have 4 kings out of 52 cards. I have 4 queens out of 52 cards. Add them together, 8 out of 52, or 2/13. Now, when you get down here to number 7, the probability that it's a spade or a jack. Well, you could have a spade that is a jack. So that is going to be an inclusive event. So we're going to find the probability that it's a spade plus the probability that it's a jack. When we have 4 jacks out of 52 cards. And then we need to subtract off the times that we added their name twice. So it's like saying I want all the freshman names plus all the Algebra 2 names. I'm adding them together. Well, I have to subtract off the ones that I counted in both groups. And that's what this means. A intersect B. It's something that is in both A and B. So we only have 1 jack that is a spade, so we need to subtract off 1/52. So we have 13, 17, minus 1 is 16/52. And then we need to divide by 4, and I get 4/13. So we have mutually exclusive and we have inclusive where the circles can cross. The next type, or this is the next type we have here is pretty much the same thing. That's just continued on those couple of examples that we just did. The last part is the probability of an independent versus dependent event. So it's when one thing influences another. So let's look at number 1. A bag A contains 9 red marbles and 3 green marbles. Bag B has 9 black and 6 orange. Find the probability of selecting 1 green marble from bag A and 1 green marble from bag B. So what we're going to do is we're going to take the probability from bag A. So the probability of A, and we're going to multiply it by the probability of B. So find the probability I select 1 green marble from bag A. Okay, well I've got 3 out of 12, so I have 3/12 or 1/4. And I'm going to multiply that by the probability that I get 1 black marble from bag B. So 9. There are 9 out of a total of 15. And we can cancel 3 out of that. So it looks like I end up with 3/20. All right. So now dependent means one influences the other. So this one, the bags were totally separate. One didn't influence the other. Now let's look at number 4. A box contains 5 purple marbles. Let's say M&Ms. 3 green M&Ms and 2 orange M&Ms. 2 consecutive. Consecutive means in a row. Draws are made without replacement, meaning after I draw it and look at it, I don't throw it back in the bag. Maybe I draw it, look at it, eat it, and then I'm drawing from the second one. So we're going to do probability of the orange. So I have 2 orange marbles out of a total of 10. So 2/10. And then the green. Now I've eaten one of the orange candies. And so now I have 9 candies left. But now I want to know I get green on the second. Well, I have 3 9s. So I reduced how many because I ate that green one. So now I can simplify. And I end up with 1/15. Now let's look at B. Both are purple. Well, I have 5 purple, so I have 5 out of 10. That's the first one. The second one, I've eaten one of the marbles, so now I'm 9. And it just so happens I ate a purple one, so now I have 4. And now I can simplify. And I get 2 9s. So that's dependent. One influences the other. It's about having replacement. When I see replacement, then that cues me in. 2 senior, like in number 2, 2 seniors, 1 from a government class are selected, 1 from each government class. So if you're selected from one government class, there's no way you're going to get selected from the other. So those are mutually exclusive events. I hope that helps.